And welcome everybody to our fields, features, flares, space weather news, solar activity, coronal holes, and more. Some exciting stuff going on here in the past 24. A couple of M-class flares. Let's take a look at the geospace around planet Earth. So we'll show you the last 4 hours here of magnetohydrodynamic pressure as modeled by the space weather modeling framework. The scale you're looking at here is nanopascals. It's Earth's magnetic moment from space. Things pretty calm in the geospace. No apparent coronal mass ejections headed our way. No geomagnetic storms in the forecast at the moment. We'll talk about possible contributors to that. You can see most of the pressure here in the magnetotail region as Earth tries to reach static equilibrium with its magnetic environment. We'll also look at the magnetic moment from the ground. First, the real-time solar wind. We've seen a little uptick here. There was also a tiny coronal mass ejection strike right here, where we saw the plasma temperature, the solar wind velocity, and the solar wind density all kick up at the same time. A little tiny coronal mass ejection. It only lasted a few minutes there, about 20 minutes. Current conditions are about 5.5 protons per cubic centimeter. For the solar wind density, solar wind speed, 405 kilometers per second. Everything else a bit unremarkable there. Moving on to the ground magnetic perturbations, Earth's magnetic moment from the ground. And things should be pretty calm here as well. This scale is nanotesla magnetic flux density, and it is the last 4 hours of geospace delta B. Changes to Earth's B field. We've got a bunch more data to blast through, so let's move it. Move it or lose it, folks. Evolve or die. The only thing that remains constant is change. We're seeing higher highs and higher lows here on the GOES magnetometers. And you see these big spiky readings here. That was the geomagnetic storm that we covered in quite in depth over the weekend on Sunday there. Significant geomagnetic storm from a significant coronal mass ejection. Anyway, that's the last 3 days. Those arcjet moments are when the GOES 16 or 17 turn on their thrusters, creating plasma and possibly affecting the magnetometer readings. Next, the heliospheric current sheet. Did you guess that we would be seeing a North Pole current sheet? It looks like it's probably already here. This data is 5 hours old. I would tend to say that we're seeing a North Pole current sheet already showing up. Any signal of that there? Not so much. May have just happened in the last couple hours. This data is 5 hours old from when we recorded this video. So here's the line of sight view of that same data. Essentially, it also shows you the solar magnetogram since you're looking at the sun from the Earth's perspective here instead of the top view. I think there is a North Pole current sheet at Earth. Next, our coronal hole line of sight plot. And we do see some well-defined North Pole coronal holes down here. They're now trans-equatorial in nature. You see right here. Pretty well-defined coronal hole there. This shows the sun's B field in blue. South Pole coronal holes in red, North Pole coronal holes in green. We'll check out the view from the SDO. You'll see 2 M-class flares in there, and we'll show some extreme close-ups of those. Here's this North Pole-oriented trans-equatorial coronal hole as the North Solar Polar Field migrates to the south, and vice versa. You can see some evidence of that happening down there. Great imagery there from the Solar Dynamics Observatory. I think it remains my favorite, quote, telescope, end quote. Next, we'll move on to sunspots. Sunspot 2965 is still very interesting, very capable of producing large flares. It's had some field migration. Make sure you watch our previous space weather video if you haven't seen that. We showed some great field migration on our colorized magnetogram imagery. Sunspot 2971 doesn't have a name yet. It ought to. It's been there for more than 12 hours. That's Sunspot 2971. You can quote me on it. Likelihood of major flares very high here. Well over 60% during part of that solar flare probability monitoring session. And let's move on to take a look visually. 1700 angstroms will show you This rising sunspot, 2971, shall be the name. Again, keep your eye on sunspot 2965. It is a major magnetic high-pressure zone on the closest star. Interesting fun fact, coronal holes are low-pressure zones on the star, and stellar low-pressure zones are so low that they blast plasma into space at high speeds. Next, looking at the GOES X-ray flux here to see two M-class flares. There's an M1.32. Make that an M1.34, I believe. The other one, an M1.59. M1.59. Peak flux of that one occurred at 2240. The other one occurred at 1230 yesterday. Both of them 1230 and 2240 were the times of those. One of the best views on the SDO, the best wavelength is at 94 angstroms. It takes 10 images per minute instead of only 2. It's specifically designed to view solar flares. And we're going to slow it down. This is about half speed right here. This is 15 frames per second instead of 30, which is what we usually show on the channel. And we'll zoom in even closer as we get more and more exciting activity here going on the closest star. We'll let that play through one more time before we get even closer. And here's the extreme close-up. We've slowed this down all the way to 9 frames per minute. You're going to see this reset. We have it on loop. And you'll see how huge those flames indeed are. Those, not flames, flares. I meant flares, not flames. And we've decided to scrub that entirely and go to the SDO browse data imagery. Because, well, there was something missing there. Not exactly sure what went wrong. We apologize for that, but to get it onto your screens as quickly as possible, here's the browse data. So there's your, in the hour of 12, M-class solar flare. Got another one around 2200. There's that other one. So let's bring that back and zoom that in. And one more run here. Peak fluxes there were about 1220 and 2240. If you want to go check them out yourself at HelioViewer or whatever. Here comes a second M-class flare. There it is. And again, no coronal mass ejections associated with that. So no relativistic particles there showing up on the GOES proton flux. At least no new ones. Planetary K index remains at 2, a KP2, geomagnetic calm conditions. We'll give you a solar system forecast. Full moon coming in a day or two. Here's where things will be in a week on the 23rd. Here's a star chart. We're always interested in what's going on above our head. The blue line is the galactic plane. The yellow line is the ecliptic. If you have clear skies and a low horizon and you're up before dawn, you may see Venus and Mars and Saturn and Mercury and Jupiter all rising ahead of the sun. It's an exciting time to view planets in the morning. And just to show you that we don't have any coronal mass ejections, here's the view from Stereo A and Lagrange 1. Stereo A at Lagrange 5, the LASCO C3 at Lagrangian point 1. From LASCO's perspective, for you new viewers out there, the Earth would be behind you. From Stereo A's perspective, Earth would be off to your right. Again, they're located at Lagrange 1 for the blue LASCO C3 and Lagrange 5, the gravitational equilibrium point for Stereo A's coronagraph. Again, no coronal mass ejections associated with those solar flares. No sunspots required for coronal mass ejections. No solar flares required for coronal mass ejections. We've talked about it regularly on the channel. Thanks for tuning in. Congratulations on realizing it exists. And may that solar wind be at your back. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off from the Smash News Network, least busted name in news.